Most inventors focus on one thing: does it work? If you're developing a physical product, the design choice that determines whether you can scale to 10,000 units or more gets locked in during your first month of engineering. But there's a manufacturing reality that only shows up at volume: tolerance stacking. Your prototype works perfectly when it's hand assembled, but when you need automated production equipment for thousands of units, suddenly quality issues explode, costs spike, consistency disappears. I've watched products with proven demand struggle at only 10,000 units because their tolerance strategy made consistent manufacturing extremely difficult and expensive. And here's the dangerous part: that decision gets made before you ever talk to a factory. Fixing it later requires major redesigns that most startups just can't afford. Let me show you exactly where this goes wrong. Point one: while your perfect prototype creates manufacturing challenges, your prototype works because the skilled technician assembled it. They hand-selected the best-fitting parts, they made micro-adjustments, they compensate for imperfections. That human compensation disappears in automated or high-speed production. Now let's talk tolerances. You design a part with plus or minus a tenth of a millimeter variation. Seems precise, but in a 10-part assembly, that variation multiplies. Now you're looking at plus or minus 1 millimeter total variation across the system. At 100 units, you're managing dozens of part combinations. At 10,000 units, you're managing thousands. Statistical variation becomes reality. Quality control shifts from does it work to what percentage of these work consistently. That's a completely different engineering challenge. If tolerance stacks aren't managed early, manufacturing costs skyrocket. You need secondary operations, manual sorting, precision machining, all expensive. Experienced engineers create a tolerance budget from day one. They allocate acceptable variation across the entire assembly. That decision happens in your first CAD models, long before you realize volume will expose the flaw. Point two: assembly methods that break at scale. Assembly methods that feel fine at prototyping stage can collapse under repetition. An adhesive bond works great in the lab, but in production, well, temperature, humidity, timing variations all create inconsistency. Press fit connections feel solid when parts are perfect, but with wider tolerances at scale, they loosen. Threaded fasteners seem simple until you have workers installing hundreds per day. Torque variation creeps in, reliability drops. Snap fit designs work beautifully in 3D printing. Translate that to injection molding. Material shrinkage changes everything. Manual alignment steps that take 30 seconds feel trivial at a prototyping stage. Multiply that by 10,000 units. Now you've created a labor cost bottleneck. The most scalable assembly methods minimize human judgment. They work regardless of skill level, fatigue, or environmental variation. That's not accidental, it's engineered. I've opened up free strategy sessions. We offer product evaluations where we analyze your design for tolerance stacking, assembly scalability, and material risks before you commit to tooling. Click on the link in the description to see if your product can truly scale. Point three: material choices that create volume problems. Materials are another silent trap. You choose something that performs beautifully in your prototype, but at scale, supply chain limitations appear. Minimum order quantities, lead times, processing constraints. Specialty plastics that machine easily may require expensive injection molding tooling. Metal alloys chosen for strength may slow production speeds. Surface finishes that look incredible may struggle with batch consistency or compliance requirements. Material cost at 100 units might feel manageable. At 10,000 units, well, processing requirements compound. And here's a big one: supply interruptions. In a prototyping phase, you can wait. In production, a supply chain delay shuts down your line. Experienced engineers select materials based on the ecosystem availability, not just performance. Scalability means supply reliability and processing consistency. Point four: the process that prevents these problems. Professional design for manufacturing doesn't happen after prototyping. It happens during concept development, before detailed CAD. Senior engineers evaluate every joint, every interface, every tolerance stack. Statistical tolerance analysis predicts assembly success rates before tooling investment. Manufacturing process selection should align with target volumes, not prototype convenience. Production validation should use representative materials and processes, not just 3D prints. Here's the financial reality: fixing scalability during initial evaluation costs a fraction of fixing it after tooling. This is exactly why our product evaluation process focuses on scalability early because production challenges should be prevented, not discovered at 10,000 units. These three scalability factors, tolerance management, assembly method selection, and material choices, get locked in during your first month of engineering. Most inventors prove their concept works, but scaling to 10,000 units or more requires designing for manufacturing from day one. The products that scale aren't always the best ideas. They're the ones engineered for production reality. Your prototype proves the concept. Proper DFM analysis proves it can support the business. If you're realizing your design might have scalability issues you haven't considered, don't spend months and thousands of dollars discovering them during production. Now you know the three decisions that determine whether your product can scale to 10,000 units or more. By identifying these issues in your specific design requires engineering experience most inventors don't have. That's exactly why we created our product evaluation service. We analyze your concept for tolerance management, assembly, scalability, and material selection risks before you spend money on tooling. Most inventors discover these problems after it's too expensive to fix them. Click the link below to book your free strategy session and get clarity whether your design can actually support the scale your business needs. And when you're done, watch my video, What You Must Check Before Building Your Product Idea. It covers the other validation steps that prevent expensive surprises. So click now.